So good morning everyone. I welcome you yet back to another tutorial. Presenting before you this wonderful tutorial is the main Hamburg Liman, and of course if you are new to this channel, consider subscribing, hitting the like button, and don't forget to share to others. We have yet another interesting question under vectors, and we have been asked to find the location of CTC relative to the location of the starting point. The question reads, a commuter airplane starts from an airport and takes the route shown in figure P171. The plane first flies to city A, which is located 175 kilometers away in a direction 30 degrees north of east, of course. Next, it flies for 150 kilometers west of north to city B. Finally, the plane flies 190 kilometers to west to city C. Find the location. Okay, we've been asked to find the location of city C relative to the starting point. Let me grab my pen. Okay, so to find this question is actually very simple. I'm going to do it in a very simple manner. So look at this. We are starting from what we have been given is this particular guy here. Okay, let me grab my ruler. What we have been given is this particular compass. So this is our compass. Okay, that is our compass. And then this is how this compass is. Just want to just draw it a bit for you so that you will be able to see how we are going to solve this question the simplest way. These are questions that you are supposed to simplify. Notice that we've got a journey from where our origin is. We have been told that this guy moved in this direction, and they are calling it as, that is a vector A. So if this is our A point, and then we have been given a 30 degrees, and then we have been told that this guy here is the plane first flies to city A located 175. If this is 175 kilometers, then of course if you have been following my videos, you know that you are supposed to compute into components. This becomes your AY and that becomes your AX. So let's find those components. We know that AX is going to equal to A vector cosine theta. So AX is going to equal to 175 cosine 30. Let's try to check what we are going to get from there. 175 cosine 30. We are getting a 151. So this is giving us 151.5 kilometers. AY is going to equal to 175 sine 30. Okay, so we're going to have 175 sine 30. And we are getting 87.5 kilometers. All right, cool. So from here, let's take another step. We have been told that this guy then moved in this direction. And then they are calling it as point B. This is where a lot of people get confused. I want you to notice how this trajectory was made. We have been showed that we have another compass moving in this direction. And then there is also another line which is moving in this direction. Okay? And then you've been showed that from this point up to this point, it's 110 degrees. Then from this point up to this point, it is 20 degrees. Then we've been told that B vector is actually 150 kilometers. I want you to notice something. Of course, we know that we can actually compute this guy into two components. So we are going to compute this guy into two components. I can extend that line on top, and then I can bring it this side. So I'm going to have two components. The first component is going to be the one which is going on top, which I can call BY. The second component is the one which is going to my left, which I can call BX. Now notice that BX is moving in this direction. This is why I was taking it. Okay, this is where it is going. Henceforth, because it's going in the negative direction, BX is going to be a negative vector. Okay, now I want you to look at something here. You have something like this. Then you have this particular triangle. They are saying that this is your 20 degrees. Of course, this is going to be your hypotenuse. Which one is the adjacent? Which one is the opposite? We know that from a triangle like this one, which we have here, we know that this becomes our adjacent. This becomes our opposite. Then we know that from SOHCAHTOA, I want you to look at this. From SOHCAHTOA, adjacent, which is in the x, is having a cosine. That is why in the x, we multiply by cosine for a triangle in this particular shape, in this particular station or posture. Don't master, just understand the concept. Then notice that opposite, which is in the y, for such a triangle in this posture, it is, we have opposite here, and it's enclosed by sine. That is why in the y, for such triangles, we use sine. Now notice what is happening. This side here, from where your angle is, that is where your opposite is, from a right angle triangle. But our angle is here, so if we do the same thing, you notice that your opposite becomes this angle, this side. This implies that this guy here is your adjacent. Now, from SOHCAHTOA, opposite is enclosed by sine. So it implies that for this negative bx, for us to find negative bx, we want to multiply by cosine, because that is the opposite. So it implies that for us to find bx, we are going to say b vector multiplied by sine theta. Okay? Don't get confused, just focus on the posture of the triangle given. That is where a lot of students get this question wrong. So bx is going to equal to, of course, a 150 sine. We won't use the 110 degrees. Use the angle given in the question. So use sine 20. What are we going to get? So we're going to say 150 sine 20. So we're getting 51. So because it's a negative vector, so it's going to be negative 51.3. And of course, by, it will be 150. Notice that the adjacent is this guy here. Okay, so like I mentioned, this is your opposite. That is why we're multiplying by b sine theta, and this becomes your adjacent. That is why we are going to multiply it by cosine. Because it was going upward, so it's going to be a positive vector. 150 cosine 20. And we get a 140.9. Okay, then we know that this is a C vector. C vector, I've been told that it's 190 due west. So due west, of course, is going this side, so it's a negative vector. And we only have one vector for C, and that is in the x-axis. So Cx is negative 190 kilometers. Cy is 0. We can add our vectors. So to add our vectors, we are going to add our resultants in the x. So to add our resultants in the x, we are going to add this guy here. We're going to say 151.5 plus, and then we're going to add this one. So instead of plus, it will be minus 51.3 minus this guy here, so minus 190. So in the x, we are getting negative 89.8. Ry, we are going to add this guy here, 87.5 plus, then we add this guy here, so 140.9, and we are going to get our 228.4 kilometers. So from here we can do our calculations. So this is going to be the resultant vector r is going to be the square root of rx power 2 plus ry power 2. So we're going to put our negative 89.8 power 2 plus 228.4. You can punch everything there. So to the so this is going to be to the power 2 plus 89.8 to the power 2. Then if we square root everything, we are getting a 245.4 kilometers. Now we can find our angle, our direction. How do you find direction? It's very simple actually. To find direction, you say theta is going to equal to tan inverse of ry over rx. This is going to be tan inverse of, this is going to be 228.4 over negative 89.8. How is our theta going to be? So we say shift tan, and then we get 228.4 over negative 89.7. and we are going to get negative 68.5. When you get a negative angle, just add by 180, and our theta is going to be 111.4 degrees. So this implies that C is stationed at 245.4 kilometers at a direction of 111.4. That is how you find for this particular question. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Thank you so much.